mechanical layout has many important features which are unique to the Daimler Armoured Car. First, the engine, which you remember is at the back, protected by this cover, which comes completely off and allows easy access to the parts which may need attention. Here is an offside view of it taken right out of the car. It has 6 cylinders, overhead valves, and develops 95 brake horsepower at 3,600 revs a minute. Right at the back is the fan, which together with the water pump is driven by a triple V-section belt. Also driven by the belt is the dynamo for battery charging with its suppressor to prevent interference with wireless. Next comes the distributor, fully screened for the same reason. The 6 high-tension leads to the sparking plugs are metal braided, also on account of wireless. Then the high-tension ignition coil. To complete protection against interference with the wireless, finally on this side is the AC petrol pump working from the camshaft. The near side of the engine presents this view. Here is the thermostat, which causes the hot water from the cylinder block to follow this path round the jacketed inlet manifold instead of through the radiator until the engine is thoroughly warm. 2 Solex dust-proof non-spilling carburetors are fitted, and on the air intake is an AC oil bath air cleaner to prevent dust and sand entering the cylinders. The exhaust manifold is on this side of the engine too, and also the starter motor. With the engine in the car again, we see the radiator right at the back and the oil filter and engine oil canister both on the offside fixed to the armor. An ordinary oil can is carried here, and on the other side cans for spare engine oil. The position which the engine, the source of power, occupies in relation to the whole vehicle is shown here. The first link in the transmission of power to the wheels is the fluid flywheel, now seen with its bell housing removed. It replaces the ordinary clutch and employs oil instead of friction to transmit power. There are only 2 parts, the driving and driven members, and here we see the driven member lifted off, leaving the driving member behind. To illustrate the principle of the fluid flywheel, let us imagine the driving member as a bowl into which we pour oil. If the bowl is revolved slowly, the oil remains in it. But as the speed increases, centrifugal force causes the oil to be thrown out in uncontrolled splashes. It is the energy contained in that flying oil that must be harnessed to transmit power. To do this, let us divide our bowl into 4 parts. Then, when the bowl is revolved, the oil is carried round at the same speed as the bowl and is flung separately out of each compartment. Let us now restrict the area by adding more partitions. Then, when the bowl revolves, the oil will be flung from each compartment with greater force. If we add still more partitions, we correspondingly increase the force of the oil until it is thrown out in a series of jets, revolving with the bowl and increasing or decreasing in force according to the speed of rotation. These jets make a driving force which can be made to turn a second bowl, provided it has similar vanes. And here is the second bowl with corresponding vanes. Let us lower it over the first until it is nearly but not quite touching. Revolving the first or driving bowl slowly has no effect on the driven bowl, but as it is speeded up, the oil jets rise from the driving bowl and beat against the vanes of the driven bowl and begin to carry it round. As the speed of the driving bowl increases, so the jets get stronger and stronger until at last the driven bowl is turning at nearly the same speed as the driving bowl. So we see how a drive can be smoothly taken up and transmitted simply by jets of oil, which is the principle employed in the Daimler fluid flywheel. The real flywheel we'll put back on the engine again. With the bell housing goes on the second link in the transmission, the 5-speed self-change epicyclic gearbox, an essential feature of the Daimler, which gives certain foolproof changes under all conditions and yet is very compact. A very simple model will show how one epicyclic gear train can affect a change of speed. First, there is a driving shaft on which a gear wheel called the sun pinion is fixed. Next comes the shaft we wish to drive with similar gear wheels called planet pinions on a fork or carrier as it is called. These planets are not fixed to the carrier but can turn on their own axis as you see them doing. Now we'll add a toothed ring called an annulus. The sun pinion then turns the planet pinions, which in their turn rotate the annulus. There is still no movement being transmitted to the carrier. Lastly, we'll add a brake which can be applied to the annulus to stop it. As soon as the brake goes on and holds the annulus still, the planet wheels begin to creep round inside the annulus. As they do this, they take the carrier round with them. If the brake comes off, the carrier stops. As the brake goes on again, you can see that the carrier is being driven round in the same direction, but at a slower speed than the sun pinion. Thus, a reduction of gear or change of speed is effected between the sun pinion, which drives, and the carrier, which is the driven member. From this simple principle has been developed the 5-speed epicyclic gearbox. The next stage in the transmission is the transfer box, which contains both the differential and the reverse gears and sends the drive out to each of the 4 wheels. Watch closely and you can see the universal joints of the 4 shafts turning. Following one of these shafts, we come to a bevel box which turns the drive outwards to the hubs through more universal joints known as tractor joints. These allow the drive to flex to the movement of the suspension. The suspension, depending on these links and great coil springs, is entirely independent for each wheel. To prevent damage to the tractor joints, movement of the suspension is limited upward by a rubber buffer and downward by a check wire. Each suspension is also controlled by an ordinary Luvax piston-type shock absorber. Steering operates on the front wheels only through these linkages. This shaft, however, leads back to the rear steering wheel, which can also turn the front wheels, thus allowing the car to be steered in reverse by a man at the back. These, then, are the main features of the Daimler Armoured Car, a vehicle designed for action, giving service for service and comparable with any which it may meet in the field.